0. Right, so what did I just do? I just plugged in that first parameterization in for x and y. Okay, now our second one, plug in x, we get
So first plug in y.
t minus 1. And now we plug into our third guy here. Added. Yeah, so these, yeah, so, oh, I see. Yeah. So what we're doing is we're splitting up our integral into 3 parts and using our parameterizations in each part. So this guy's neat. 0 dt, that goes away. d0 goes away. D of a constant, derivatives of constants are 0. Goes away. And now here we actually have some stuff to do. So we've got 1 dt minus 1. Okay, so noticing that we've got a minus and a plus here. When we group the d3 minus t's out, this whole thing will go away. So we get a very nice kind of, at the end we get a very nice, pleasant sort of simplification here. Comes down to 1, which is just lovely. But what on earth does this have to do with 1? Right? We've got this crazy vector field. This guy, you know, we've got this vector field something like this. We integrate it over this boundary, we get 1. Who knows? So I want to do a much simpler, much cleaner example that'll suggest what this vector field's really measuring.
This is getting harder. Looks. They should give us a formula sheet definitely. No? So many things to remember. And नहीं बहुत मुश्किल नहीं है सर इसका फॉर्मूला हिट होनी चाहिए नहीं होनी चाहिए
होनी चाहिए ऐसा कहना दे 157
So this is big and messy because we had this crazy piecewise orientation, all this nonsense.
अब स्टैट्स में तो मिलती है
फॉर्मूला भी लिखे होते हैं फॉर्मूला भी लिखे होते हैं 157 में
कौन से फॉर्मूला
ऐसा लिखे होते हैं
आगे लिखे
ये लिखे होते थे यार डिफरेंशिएशन के इंटीग्रेशन बाय पार्ट्स को
नहीं इंटीग्रेशन में पार्ट के फॉर्मूला लिखे होते थे ऐसे यार
हाँ लिखे होते थे मुझे शायद नहीं चला जितना मुझे याद पड़ता लिखे होते थे
अभी तुम सर्कल में कर रहे हैं सर्कल में वेक्टर फील्ड का क्या काम
Now we'll look at one of the nicest, most elegant parameterizations, and hopefully that'll give us insight into what the heck this vector field's doing. So here's a counterclockwise orientation again on the unit circle. And now let's try out the integral again. It goes 0 to 2 pi. Oh, sorry, that should be T's, sorry.
and that should be T
So yeah, we take Y, so that should be sine of T. Okay. Okay. Mysterious observation. Notice that both times, in this example and this example, we wound up integrating 1.
Is that displaying like the boundary since it connects at the all the way? It would just be a whole like it would be like the whole t value.
Sure, yes, that is true. That is what's going on. That somehow, because this shape closes up, we wind up just integrating something really nice. So you got these two measurements. Right, we've got a measurement that says, all right, when I integrate on the boundary of this thing, I get 1, and when I integrate on the boundary of this thing, I get 2 pi. What's this thing measuring? Who connects these observations?
by r square radius is
Strange. So, okay, so
उसका base 1 है ना
somehow we integrated the same vector field both times, right? It's still this negative y x guy. Here we got 2 pi, here we got 1.
it's the 2 times the area
Is it 2? Oh, yeah, sure, was it? Yeah, which is pretty cool. So yes, so a couple people said, is it 2 times area? And it turns out it is. And what's crazy is that that took people like 100 years to figure out. So people were calculating this thing and being like, they're just like, line integrals. And now you guys got it in like the last minute of a lecture. It's amazing. So yeah, so this is, so this guy has area equals pi.
जैकोबियन ये क्या हो गया?
This guy has
अहमद, हमें किसी चीज़ की एरिया फाइंड करना नहीं आती है ऐसे करके, लेकिन फिर
right, so yeah, so there's a relationship between that length of the boundary and the area. Yeah, totally. So what we're going to be able to explain next
नहीं तो हमने
lecture
फंक्शन यही क्यों दिया?
is the following observation.
नहीं तो उसी से तो आया ना, सबसे थोड़ी आया ऐसा। अहमद,
सबसे आता होगा तभी तो पढ़ा हो रहा है वरना पढ़ा है एक ही हो मुझे लगा कि हमें कभी यूज़ नहीं करना पड़ेगा
क्या?
जो कभी यूज़ नहीं होगा मतलब वैसे एप्लीकेशन में यूज़ होता है लेकिन इंटीग्रेशन वगैरह की यूज़ होती है जैसे तुम्हें पढ़ा ना 338 है सीरियसली 338 है न्यूमेरिकल मेथड्स अप्रोक्सीमेशन उससे होती है ज़्यादातर इतने नीट फंक्शन नहीं आते कि आप उनको इंटीग्रेट या डिफरेंशिएट कर सकते ज़्यादातर अप्रोक्सीमेशन करनी पड़ती है अभी पढ़ाएगा ना
आर्नल्ड क्या पढ़ेगा?
आर्नल्ड ने थोड़ा बहुत तो बताया था ना उसने उसके बारे में फ्लोटिंग पॉइंट
फ्लोट
Right, so we'll be able to explain the following observation next lecture, that twice the area is the integral of this vector field. So if you can measure this vector field over your boundary, then you can get your area. Okay. So next up, we'll explain how this connects up to the fundamental theorem of calculus. We'll look at Green's theorem itself, and carry on.
चल मैं निकल जाऊँ